Hello, my name is John Siccardi. Today I'm going to talk to you about Pi's line of milliamp and voltage loop calibrators. Our model 334 is our milliamp calibrator, which has been designed as a direct replacement for the Altec 334A. With this calibrator you can simulate a 2-wire transmitter, source anywhere from 4 to 20 milliamps, read current up to 50 milliamps, and also power and measure a transmitter. Simply slide the switch to the on position and you can look at 4 to 20 milliamp outputs. In the low position, you're at 4 milliamps. Switch to the high of the easy check switch and you're at 12 milliamps in the center position. The next calibrator in this line is our Pi 334 Plus. The Pi 334 Plus has all the same features as the Pi 334, including our patented current leak detection. Current leak detection allows the technician to find current that's bypassing a transmitter. It can be due to problems such as moisture, corrosion, or ground faults. With the Pi 334 Plus, simply put the unit into power measure mode by adjusting fully counterclockwise. And what you'll see is on the bottom of the display, it is now looking at the leakage current in the loop. If leakage current is found in the loop, it will be displayed on the 334 Plus. Our Pi 434 has the same features as the 334 Plus, but also has other automated functions such as stepping and ramping. It also has a 250 ohm heart resistor which can be enabled, along with auto on and off and backlight that can be turned on and off. The 434 is also a high accuracy calibrator, up to 0.01% of the reading. Pi also has two calibrators which source and read voltage along with sourcing and read current. The Pi 532 for 4 to 20 milliamp loops and the Pi 535 which does 4 to 20 and 10 to 50 milliamps. 10 to 50 milliamps still being used in some of the older power plants. The 532 also has one of our patented diagnostic functions. Simply put the calibrator into diagnostics mode. The display will tell you current on the loop, voltage on the loop, resistance of the loop, if there's any leakage current, and also any AC voltage that can be on the loop. Now what we'll do is go through a demo of our patented current leak detection. Now we'll do a demonstration of our patented current leak detection. For this, we've created a process control loop that consists of our Pi 334 Plus calibrator, an RTD transmitter, a display indicating our control room that monitors the loop, and an RTD simulation. The Pi 334 Plus calibrator will be set with leak detection on and will turn on the power measure mode. Again, this is done by depressing the speed dial and dialing it clockwise to the full position. The calibrator is now powering the loop and simultaneously monitoring the output of our RTD transmitter. As you can see, the output is 4 milliamps. The leakage current in the loop is displayed on the bottom line of the display. And as you can see right now, there is negligible leakage, 0.01 milliamps. Our control loop is set up as a 0 degree being our low signal, corresponding to 4 milliamps on our control room, and a high signal of 100 degrees being 20 milliamp output. This loop is now in control. Now, what happens if we introduce moisture or condensation in a junction box or into conduit, say after a heavy rain or humidity conditions in the south? The control room sees a problem and a technician will be dispatched to find out what the issue is with the loop. We now have about 0.2 milliamps of uncontrolled current being seen at the control room. The Pi 334 Plus is also displaying the same measurement as an output of the transmitter of 0.224 over the expected 20 milliamps, and the leakage current now is also being displayed, 0.22 milliamps. The problem with leakage current in a loop is that it's bypassing your transmitter. So if you go and replace the transmitter and put a new one in, there will still be a problem with leakage current. The other option, which is done in error, will be to try to adjust the transmitter to take the output of it down to 20 milliamps. The difficulty and the danger there is now we've adjusted a loop incorrectly because there's a problem with moisture condensation in the loop wiring. Only the Pi 334 Plus or Pi 434 or several of our multifunction calibrators have our patented current leak detection. By having it displayed on the unit itself, a technician will not have to go out and try to change transmitters only to find that the problem still exists. That concludes our discussion today on Pi Milliamp calibrators and our current leak detection.